Hello everyone. While waiting for everyone to log in, I would like to spend a couple of words on how to use the program you have already installed, I guess. You all have a control panel where you can manage two things, the audio and a question field in which we will give you the answers to the questions you will ask us. From time to time during the presentation, we will decide whether to stop and respond immediately to some of your questions rather than at the end of the topic. And at the end of the presentation, instead, we have a small inquiry for you where you can vote on what topic you would like to see during our next webinars. So I will wait for a few seconds, and afterwards we can start with the presentation. Okay, I think we can start now. First of all, good afternoon to everyone again. I'm glad to see many familiar names in the list of persons that are people that are participating today, and also people that probably are not that familiar with our group. So for this purpose, I will make a brief presentation of Amada. My name is Nikola Dimitrov, as some of you probably know, and I've been part of the Amada family for several years now in the role of a sales consultant for the Balkan area. Among the states that me and the Amada Italy subsidiary is covering are Slovenia, Croatia, Bosnia and Herzegovina, Serbia, Montenegro, Kosovo, Albania, Macedonia, and Malta. The Amada Group is recognized among the world leaders in machine manufacturing for the sheet metal sector. And today we are here because, like everyone else in this period, we have reflected on the best way to integrate our usual working processes and how to adapt our actions towards our clients. What we have missed the most in this period is obviously the contact and the conversations that we usually have with you and that allow us to work together. For this purpose, we have decided to digitalize some of these processes. As I said, for this purpose, we have prepared a series of appointments for you that we will promote on our social media and on our website. And the aim of these appointments is to answer all the questions that represent the basis of yours and our improvement and growth. Today, we will introduce our vision of control and flexibility, dealing with the most important aspects of the transition process between the cutting and the bending phase. We often look at the solution, search for the solution in the micro phase, but we also consider that it's not unusual to find the solution of these problems in a jungle of macro phases and manual operations that tend to be neglected. Before leaving the word to my colleague, I would like to introduce him. It's Mr. Matt Wood from Amada Europe, that probably some of you already know, and he is responsible for our blanking department. So I will leave the word to him now, and I wish you a pleasant streaming.
Okay, thank you, Nikola. Good afternoon again, everyone. Just a quick introduction. As Nikola said, my name is Matt Wood. I'm the EU Blanking Product Manager. I've been with Amada over 20 years now in different roles, software, sales consultant, looking after the showroom and so on. But today, as Nikola explained, I'd like to go through using some slides some of the typical problems we find between blanking and bending processes. Now, to do that, I'm going to use a presentation. So if I share my screen with you now, hopefully everyone can see my presentation. I know Nicola just gave you a brief introduction, but just let me repeat a few points. We were founded in 1946 in Japan, and we are among the world leaders for sheet metal working systems. Our four main strategic areas are Japan, Europe, North America, and China. We have more than 90 companies in the group, including sales branches, production plants, and other partner companies. But the main thing we want to focus on today is the technological solutions and services that we can provide, particularly how we can customize some of those solutions for each customer's particular questions and issues. Very quickly, some of the products we produce: laser cutting machines, punching machines, punch laser combination, bending machines, both standalone and fully automated, fiber laser welding systems, automation systems, and the software that runs everything. But really the main point in red at the bottom is the integrated solutions and how we can customize them based on the customer requirement. But we don't just want to be a machine supplier. So from our support side, we have pre and after sales support, internal support, and also field service. The four areas really that Amada were founded on almost 75 years ago and that we still use a lot today are technology, precision, reliability, and ecology. And Amada Italia are located in Pontinuri, and here is one of the largest design study spaces and exhibition areas in Europe, and it's open every day to accept customers, to show demonstrations of the machines and systems, and listen to the voice of the customer to see if we can help in any way. Okay, on to the main part of the presentation, blanking to bending and turning problems into results. Our target is to offer innovative solutions to help customers become more efficient. And we want to do this in three ways. Firstly, to come up with a tailored solution to a customer's particular problem. We want to be able to create a continuous working cycle, because that way we increase efficiency, which will increase the profit and so on. But also try to avoid the so-called bottleneck. And as we'll explain later, quite often we find that this bottleneck on the production side is in the bending phase. But we will go into that a little bit later on. If we consider the way that a lot of customers work as a kind of a standard process and the issues that people commonly see, over the last 70 or so years, we've done a lot of studies at customers' factories to understand the workflow and their problems. Generally, we find that customers have a good performance in the blanking phase. Customers understand the issues, how to solve them, and so on. The real problems begin at the bending phase. Often there's repeated work, parts are folded incorrectly, the blank size could be wrong, and so on. And it's really what we call macro phases between the blanking and bending that can also cause the problems. So these micro phases, or manual, semi-manual operations, are things such as setting up of the machine, or it may be adding inserts to the part, finding the tooling, setting the tools up themselves. And anytime there's a manual or semi-manual operation, that's where the timing can take longer, costs can increase, and so on. These micro processes between the two macro phases can seem, by the name micro, they may seem small, but actually they have a very big effect on the time and the cost.
We have received our first question from the panel, Matt, that is closely related to what you were saying now.
Okay.
What are the main factors that affect productivity most?
Okay. Probably, often we find it's not the machine. It can be other things, maybe the material availability or the part availability. So for, I guess if you imagine you're making an assembly of 10 parts, if only 9 of them arrive at the bending machine at the correct time, then there'll be some delay in the production and so on. There can be setup mistakes on a punch machine, for example. An operator could cross a punch and a die, which leads to machine downtime and production delays. And sometimes also programming delays. There may be a problem with the processing of a customer's part or a 3D model. So there can be a lot of problems away from the machines that actually cause problems on the production side. Hopefully that answers the question. From Amada's side, something we call the Amada formula consists of three things. We're aiming for high efficiency, high productivity, and zero mistakes. So what we're trying to do now is to virtualize the whole prototype process and try to combine these micro and macro phases with combination systems and automation products. One thing that we're seeing more and more is the ability to utilize highly skilled operators, maybe at the front end of the factory. So maybe in the technical office, for example, to utilize their skills to make the production flow better down the rest of the factory. So if we consider the virtual world, from CAD to virtual prototype without waste, we first started using a system called VPSS, Virtual Prototype Simulation System, maybe in 2004 or 2005. And the idea being that we take the customer's 3D model or the 2D drawings and we virtualize the prototype phase and we create the correct flat blank development based on things like the dimensions that are on the drawing. That could be a 2D part or a 3D model, the thickness and type of material that we're going to be using, but also the bending tools that we're going to be used. They are particularly important when you're considering the flat blank.
Talking about the tools, a member of the panel is asking why was it important to consider the tools in this calculation?
Okay, we have a lot of experience with bending machines, and we understand that the bend allowance has a huge effect on the flat blank. So say, for example, a customer sends you a flat blank to produce. He may have used a K factor to develop that flat blank. But when your operator puts the flat blank onto the bending machine, maybe he'll use a 8mm V, for example. That has a specific bend allowance, which could well be different to the K factor the customer used. So this means when the operator folds the part could be wrong. It could be too big or too small. So what we do in the VPSS 3i package, we tell the system exactly which tools we have available, and it knows the bend allowance for each V and each tool and so on. So we can actually take a customer's, say, 3D model, and it doesn't matter how they've drawn the part, we can develop it based on the tools we're going to use to make sure it's the correct outside sizes. So that's why we use the bending tool information. One very important thing about the Amada solution is the centralized database that we use. So after all the cutting and bending programs have been created offline and simulated in the Amada CAM software, everything is saved to a database that we call VSDD. And that manages the entire process. Everything the operator needs is in this database. So imagine we've made the flat blank already. We move on to the bending phase. The press brakes now are all managed through the AMNC 3i control. You can see the image on the left. So if the operator just scans the setup sheet or calls in the program, what they'll see on the screen, as you can see on the left, is the type of tools and the tooling layout, the correct blank with the bending sequence all loaded onto the screen. And this view can be customized by the operator. One operator may want to see it from one angle, another operator from another angle. That can be customized on the screen, but the program with all the tooling has been created offline away from the machine. So this VSDD database is really central to everything that we do now with the machines and the software.
We have received another question from the panel.
Okay.
It seems to understand that the goal is to make the management of technologically complex and advanced machines simpler and more effective. Is that correct?
Essentially, yes. I guess everyone knows it's getting more and more difficult to find skilled operators, particularly on the bending side of production. So we're having to design machines that can do more and more automatic functions. But if we just did that and didn't consider the control side, the machines would be really complex to use. So what we've worked hard on is the new interface for the AMNC 3i controlled machines to make sure they're as simple as possible to operate, although they're a high technology type machine. And a lot of it is because it's linked to the offline software. So yeah, we're trying to make them as simple to use, but also doing as much automatically as they can. And by using this database, we're not relying on one operator to fold a particularly difficult part. In the past, maybe one guy knew how to fold this part, but now any operator can go on the machine, call up the program, set the tooling, follow the bend sequence. So yeah, we're trying to make them as easy to use as we can. We see that there are three main advantages to this virtual world. The first is that you know for sure that you'll get a very low error percentage rate when you go to fold the part. And hopefully the waste of raw material is close to zero. You've already proven offline that the parts will fold with the tooling you have and that there's no collisions with the machine and so on. So the idea is the first part you fold is correct. The second point is increasing the level of production efficiency because of this low waste of time and material, but also the ability to use maybe lower skilled operators with limited experience to do some more complex folding work. And the final one that everyone needs to consider is the time and cost. And because things have been done virtually, you can have quite a good understanding of how long and how much it costs to actually make a part to make sure you can create an accurate quotation.
A very interesting question has arrived. Are these three advantages your answer to lean manufacturing?
To lean manufacturing?
Yes.
Yes. Lean manufacturing is it's a difficult task because it's small increments all the time that make the difference. No customer can ever say we are 100% lean. So it's something we've been working on for a long time and will continue to work on, is to come up with new technologies, new solutions to help make customers more and more efficient all the time. So 100% lean is almost like a target that you never quite reach, but we always try to get there with new technologies and systems. So yeah, it's like our answer to lean manufacturing. This slide we've called only precise production information. Really, because of the way the machines work now, they have barcode scanners attached to them. The software can produce a sheet that has the barcode and maybe the program name. And really that's all that the operator needs. He can take that setup sheet, scan the barcode, everything appears on the control that he needs to set up the machine and run the job. So again, it's trying to keep it as simple as possible.
Another brief question.
Oh, yeah.
Is the production sheet customizable?
Simple answer is yes. You can expand the production sheet. So you can have the image of the tooling layout with the tool information. You can have the bending sequence shown each step if you wanted to. So it is customizable in the software. But as I said, really the basic thing the operator needs is the barcode and maybe the program name. But yes, it is customizable. it's okay creating everything in a virtual world, but you want to be able to check that the thing that was actually produced took as long as you thought it would, and they're as efficient as you think you are. And we can collect the data, the production data from the machines using a system called vFactory. And I'll explain a little bit more about that towards the end of the presentation. We mentioned earlier macro and micro phases. So we consider the macro phases to be the blanking and bending, but there could be quite a lot of micro phases, things like inserts in the part and so on, chamfering perhaps. So what we'll do is we'll have a look at some of these, and really there's two main problems, two main pitfalls to micro phases. They can be manual or semi-manual processes depending on what needs to be done. But the two disadvantages really are time and cost. Because if it's a manual process, there's no guarantee how long it will take. One operator may take 5 minutes, another operator may take 10 minutes. But if you made your quote based on 5 minutes, then immediately it's cost you more to produce. So the time and the cost are really important with these micro phases.
A participant is asking who makes the tools we use.
We do. Armada make all the tooling that we supply. So we have tooling factories in Europe, Japan and North America. And the reason for that is we don't just want to be a machine supplier. We want to be able to understand customers' real problems and help to solve them one by one. And the best way for us to do that is not just to supply the machine. If we supply the tooling has been designed specifically to work with our machines. So that allows us to be a one-stop shop for all our customers. That's maybe the best way to describe it. So machine, tooling, software, automation, and so on. But to answer the question, yes, Armada make all our own tooling. Okay. One example of a machine that can incorporate these micro phases is a machine we do called the EMLAJ. So we call it a complete work center. It has a fully electric punching drive system. The laser cutting side is taken care of by Armada's own in-house designed and developed fiber laser source. And on this machine, it's 3 kilowatt because we realized quite early that 3 kilowatt is really the ideal power for a combination machine based on the thicknesses people tend to process. But it can do lots of other processes as well, such as forming, burring, tapping. We have a system called V-cut that just cuts a small V notch in the part, so you get a very tight internal dimension. And the machine can take care of everything. So you put on the raw material, load the program, press start, and the finished part comes off. You don't have to do any secondary processes. And again, as we said earlier, all the information, all the management of this is connected to the VSDD database. The other side is also thinking about the setup of the machines, particularly tooling setup. And on the bending machines, I said earlier, we've done many studies over the 70 years or so. And it's often been proved that the press brake, the tool setup of the press brake can take up more than 70% of the actual machine power on time. So we know from doing these studies that customers who have multiple press brakes, maybe if the machines are turned on 10 hours a day, on average, they're doing 3 to 4 hours folding per day. So many customers believe they're much more efficient, but in reality, when you stand and you watch what happens on a shop floor, myself and Nicola and other guys in Armada Italy have done this. We just stand on the shop floor and watch what happens, and it often proves that it's this sort of 70% is tooling setup. Other time also is lost through creating programs manually on the control, selecting which tools to use. An experienced operator can do that much more quickly than an inexperienced operator. Finding the tools is always fun. Sometimes they're near the machine. Sometimes they've been used on another machine. They're not where you expect them to be. And then you've actually got to set the machines up as well. And all this just adds more and more time that the machines aren't producing. So what Armada have developed are several automatic tool setup systems. We have one on the bending side, two on the blanking side. So on the bending side, a system called the ATC, which is Auto Tool Changer. And on the blanking side, we have PDC, which is Punch Die Changer, and TSU, which is Tool Storage Unit. But all three systems have the common feature that they automatically load the tools. So in stage number 1, for example, the operator just scans the production sheet with the barcode reader. That loads in all the information about the program and the tooling that's required. In stage 2, regardless of which system, the robots take the tools from the storage system and automatically load them into the machine. They load them onto the upper and lower beams of the bending machine or into the storage turret of the punching and combination machines. And that can have a really big effect on the setup time. Can reduce it 4 to 5 times. In the third stage, everything is loaded in the machine, programs, processes, and tooling. So the final point is you load on the sheet of material, press start, and let the machine do the work.
A somewhat complex question has arrived that I will try to synthesize it as best as I can.
Okay.
All these solutions to reduce tool setup times are intended for those that work with large batches. And do you have any advice for those who produce pieces of different materials and thicknesses and with reduced quantities?
Okay, I would probably say the opposite. Sorry to whoever answered the question, but probably automatic tool setup is more beneficial for companies who have small batch work. So they're always changing the setup of the machine. We said earlier that we've done many studies on the machines over the years, and we know for a fact that, say, on a press brake, the setup time can be 20 to 30 minutes on average. The ATC system on the press brakes can change all the tooling in around 2 minutes. So you can see immediately the effect that has on the productivity. And if you're changing jobs 8 or 10 times a day, you could be saving 3, 4, 5 hours per day just through automatic tool setup. But that doesn't mean that customers doing large batch sizes don't benefit. The benefit for these customers really is the consistency, because you know where the tooling is because it's in the machine storage unit. So there's no danger of someone having taken a tool and used it somewhere else and you can't find it. And also from the efficiency side, say on a punching machine, it will keep a log of how many hits each machine has done. So you can schedule in some preventative maintenance, for example. So I think the auto tool systems are more beneficial for customers using small batch work, but even customers with large batch quantities, they still get some of the benefits at the same time as well from the consistency. Hopefully that answers it.
Well, another question has arrived related to our PDC system.
Okay.
With the PDC, if there are two same tools in storage, will machines swap tools after a predetermined number of punches?
You can set it to do that, yeah. As I said just a moment ago, you can keep a log of how many hits each tool does. And if, I don't know, say the number of hits is set to 300,000 or something, when the machine registers that tool has been used that much, it will take it out and change it for an identical tool. So yeah, it can be used for that, yes. We are often surprised by the results that we can help customers achieve, and I think customers also are very surprised. As I said earlier, often customers believe they're very efficient, and then we make some simple suggestion perhaps, and it can really help. So as a company, we set ourselves some very high targets. We want customers to be 90–95% efficient, and that's a really big challenge for us. But using the types of systems that I've mentioned to you already, that's what we're aiming for. So as I said earlier, we want to listen to what we call the voice of the customer, and we want to understand all the production problems and help solve them one by one and increase the overall efficiency and productivity.
A participant is wondering, what are the main factors in achieving these ambitious goals?
We've already discussed kind of some of the systems, but I guess we want to be more than just a machine supplier to our customers. We don't just want to sell a machine and then turn up 1 or 2 times a year to service it. We want to, as I've said maybe once or twice, we want to understand the problems and help customers solve them. Our company motto is, our company logo, if you like, is growing with our customers. So we can only succeed if our customers succeed. And our way to do that is to keep in constant contact with the customer and understand any problems they have. So that's really the main thing for us, I think. Okay, I mentioned earlier, we have a system called vFactory, which allows us to collect all the production data from the machines, but it fits perfectly with the Industry 4.0 ideal. So I just want to spend a couple of minutes explaining something about this system. It's really in 2 halves. We have a service and maintenance for the machine management, and consultancy and performance to help improve the efficiency, which is one of our main goals, as I've said several times. If we look at the service and maintenance side, what vFactory allows us to do is to do some kind of predictive diagnostics. So we can monitor things like on a laser, the chiller temperature, for example. You can see on the left-hand image that we can also monitor the productivity of the machines. When are they running? When are they in setup time? Is there some alarm time, and so on? There's also a system called a vMonitor. Now, many blanking machines now have webcams installed, which just allow maybe the company owner or the production manager to check if the machine is running, and particularly in unmanned situations. vMonitor is more than just a webcam. Firstly, it has night vision capability. So even if it's running at night without the lights on, it can still see what's happening on the machine. But one big problem we found for many years is a customer rings us and says there's been a problem with a punch machine, for instance, a particular job. But it's really difficult to understand what was the machine doing when it had the problem. With vMonitor, it's actually a recording system as well. So if there's some alarm that appears on the machine control, it will store a certain amount of time before the alarm and a certain amount after the alarm. And then our service support people, they can log into this system and they can check the video playback. And this makes it much more efficient to be able to fix the problem on the customer's machine, which then means the machine can be back in production much more quickly. We also have the ability with the AMNC controls to connect to them remotely and do remote diagnostics as well. So when we combine that with the vMonitoring system, we're trying to do everything we can to make sure that either we predict the problem in advance and we make a service visit to make sure that doesn't happen, or if there is a problem, we can solve it as quickly as possible by having all the facts, the alarm data and the video playback data. On the other side, we have consultancy and performance. So this is where we can check all the information. Again, you can see in the image on the left, we can check all the production, optimized data such as alarm time, setup time, operational time, and so on. And it's quite interesting to discuss with customers about the alarm time, because we may see that there's a common alarm that is created when a customer either runs a particular job or runs a particular type of material. And maybe we can help to propose some changes to make, maybe it's a program change that's needed to make sure that the alarm time is minimal. So we're trying to do everything we can to increase productivity and keep the system downtime to an absolute minimum. So I'm getting near the end now. I think to sum up, Armada want to be a real partner for our customers moving forward into this industry 4.0 ideal. And as I said earlier, the voice of the customer is really crucial to us. So we want to understand your production needs, what are your goals, what do you want to achieve in the future? And hopefully by collaboration, we can solve those problems and help you achieve your goals. For me, that's everything for the moment. Thank you very much for attending today. I hope you've found it useful. And I will hand you back to Nicola.
Thank you, Matt. I hope that you enjoyed Matt's presentation. I know I did, and that you found it useful. In case you have any comments or suggestions to make, feel free to write us on our social media profiles or through the usual communication channels, and we will definitely answer all the questions that you have. Before leaving you though, we would like you to answer 3 questions that are part of an inquiry that will allow us to choose the topics for the next webinars. This is the first one. Okay. The second question. And you will see the third one in a few seconds. Okay. Before leaving, I would also like to remind you that our next webinar will be held on Tuesday, June the 30th. So if you have time, please feel free to follow us. And in case, as I said, you have any suggestions or comments to make, follow us on our social media profiles and write us an email.